In previous lessons, we had detailed videos going over the process for hypothesis test for 3 different scenarios. 1, if we knew the mean but the standard deviation was known. 2, if we knew the mean and we didn't know the population standard deviation. And 3, when we're looking at the population proportion. The goal of this video, now in all of those videos, each of those topics was separate. So in that video, you knew all the problems you were dealing with were that particular problem. The goal of this video is to say, now that we've learned these 3 different methods, if we're just presented with the problem, based on the wording of the problem, can we identify which of these 3 methods we need to use? Now, to help us organize our thoughts, I've written out this flowchart here. Let's start reviewing the flowchart. Your first big division in thinking about what hypothesis test do I use is, as you read the problem, you need to identify, does this problem deal with mean or population proportion? Because if it deals with the population proportion, there's only one option that we learned. You know you would complete the problem via this method. Now, if you recognize the problem deals with the mean, you then have to further investigate. What do you then have to check? Once you know it's with the mean, you then need to figure out, do I know the population standard deviation, or is the population standard deviation unknown? So the difference here will be, in one case, we know the overall population standard deviation, and in the other case, we just know about the sample standard deviation. Now, once you've identified which method, you would just follow through the steps that are outlined here, and these steps were outlined in the previous sections of notes. So you can look back in your notes and read through each of the steps. So let's proceed with the examples, the remaining examples of this video. And during this time, I really encourage you to pause the video before each example, read through it, and think through to yourself which of the 3 methods applies for the particular problem you're looking at. So here we have that a random sample of 50 public school teachers in Georgia had a mean annual salary of $48,300. Assume that the population standard deviation is $8,000. Can you conclude that the mean salary of public school teachers in Georgia differs from $50,000? Use the alpha equals 0.0 level of significance. Take a minute and pause the video if needed. Based on the phrasing of the problem, which of these 3 hypothesis tests should we be looking at to complete this example? So hopefully you've had some time to think about that. Let's highlight our keywords. The first thing I notice is I'm given information about the mean, which we're given information about the mean also in the population proportion. That's not the big deal. But additionally, the real thing that I focus on is that they mention the thing I'm trying to determine, my question, has to do with the mean salary. That's the real deal. Not because the mean is mentioned earlier, because we always know about the population mean or the sample mean, but because the question has to deal with the mean salary. So at this point, we know we're one of these 2 tests because we're dealing with the question about the mean salary. Now we just have to determine, do we know the population standard deviation, or is the population standard deviation unknown? We see that we're actually given the population standard deviation, so from that, we know that we're dealing with this particular method. Now that we know the method, we would just find the different steps outlined in our notes and we'd follow through the process. So let's record a few key details. First of all is our N is 50. That's our sample of 50 public school teachers. Of that sample, the mean salary of the sample was $48,300. So that's our sample mean, X bar. Now we know the population standard deviation, not the sample standard deviation. The population is 8,000, so that's my sigma is $8,000. And I'm also going to record here that I was told to use alpha, my level of significance 0.01. So here we're collecting all the necessary pieces of information from the problem. Next, step 1, we write our hypothesis test. Now, in particular, this video is both meant to be a review of our 3 different types of hypothesis test and an opportunity to test your understanding since you've seen each of these types of hypothesis tests in their detailed standalone videos. So right now, and I'll introduce this many times, I encourage you to pause the video and write out what is H0 and H1 for this problem. Pause and attempt right now on your own. The question we seek to answer is the mean salary, our mu, different from 50,000? Well, in order to answer that, we first have to assume that it's the same as 50,000. That's our null hypothesis. And then the alternate hypothesis, what we're testing is it different than that? So different is not equal to. And while this is fresh on my mind, I'm going to record, is this left-tailed, right-tailed, or two-tailed? Because it's not equal to, I know I'm dealing with a two-tailed test. And remember, where are these steps coming from? You can find it in your notes earlier. The steps for this is listed out one by one. Step 2 says find the level of significance and record that. We've got that already. Alpha is 0.01. Okay, step 3 is to calculate the test statistic. From our process described here, I know the test statistic is Z is equal to the sample mean minus our mu naught divided by population standard deviation divided by square root of the sample size. Now, where is our mu naught coming from? Mu naught is where our hypothesis test is based on, so it's our 50,000. We've already got our sample mean, 48,300, and we've got our population standard deviation and sample size. So as before, take a moment now to pause the video, calculate the test statistic on your own, rounded to 2 decimal places, unpause to check your work. So here I've got my 48,300 minus 50,000, all divided by 8,000 divided by the square root of 50. And when I type this into my calculator carefully and round, I'll get to 2 decimal places. Negative 1.50 is my test statistic Z. So while I could complete this problem using a critical value or a p-value method, here I'll just show the p-value. If you prefer the critical value, you can attempt the problem on your own in that way. We know the next step, if we're doing the p-value method, is to find the p-value, and I'm going to draw a quick sketch to help me visualize this situation. I found that for my two-tailed test, my test statistic is negative 1.50. So I know I've got my negative 1.50 paired with my positive 1.50. And the p-value is then the area before the negative 1.50 and after the 1.50. Now, how will I find that? This is our normal chart. I'll find this from my cumulative normal distribution chart, which we've been using repeatedly. Let's bring that on the screen. And we know from this chart, I can read at negative 1.5, here's the row, here's the column. So I've got an area before negative 1.50 of 0.0668. And by symmetry, that exact same area is mirrored on the right side. Now the p-value is the area enclosed that we're interested in that I've shaded here. So for me to find my p-value, I would actually have to have 2 times 0.0668 because I've got 2 branches of this, which would give me a p-value of 0.1336. Now if you're doing the p-value method, the thing that you need to check is that you reject H0 if the p-value is less than or equal to the significance level. If the p-value exceeds the significance level, we have to fail to reject H0. So here, my p-value is definitely not less than my alpha value of 0.01. Because it's not less than, I've got to fail to reject. And then all that remains at this point, the calculations are done. We've just got to write a proper conclusion. Take a moment to pause the video and write out your conclusion to this hypothesis test. So as it's a fail to reject, we have our basic fail to reject starting phrase. There is not enough evidence to conclude, and then we just follow up with whatever we are trying to determine in this problem. So our answer here is there's not enough evidence to conclude that the mean salary of public school teachers in Georgia differs from $50,000. So our next example says the General Social Survey asked 514 people whether they have ever considered a career in science, and of those surveyed, 178 said they had. From this, can you conclude that more than 30% of people have considered a career in science? Use the alpha equals 0.05 level of significance, so we can tell from the problem that we're dealing with a hypothesis test. But at that point, we now need to say, okay, well, I know 3 different hypothesis test methods as of now, so which of those methods is correct here? I'd encourage you to right now pause the video, read through the problem again, and identify which of these 3 methods for the hypothesis test should we use here. So as we read through, I notice a few key details. First, I've got a big sample, and of that, I've got a smaller group that talks about the topic I'm interested in. So here, what are we interested in this problem? Considering a career of science. I've got 178 out of 415 of my sample who considered a career in science, and I'm trying to compare that to a proportion in the wider population who considers a career in science. So from this phrasing, even though I don't see the word proportion written in the problem, the fact that they're giving me a sample proportion and we're asked to, from this, make a decision about the population proportion, a percentages are proportions, that tells me we're dealing with this method, population proportion. So now that we know the method, we would quickly review the steps and then go about the process to complete our hypothesis test in an orderly and organized fashion. Now, first things first, we extract the key bits of information from the problem. So first, I see that I've got a sample of 514 people. Of those sampled, X had the characteristic we cared about, specifically for this problem, considering a career in science, so 178 is that value. Now, my 30%, I know I need to change that percentage to a proportion. Move the decimal place over twice. This is 0.30 is the proportion we're looking at in the general population that we're curious about. Now, from the sample, I get my p-hat value, my sample proportion. And by the formula that you can see here described, it is the number in the sample that have the characteristic you're looking for divided by the sample size, which for us is 178 divided by 514. Now I type this into my calculator. It's not a nice terminating decimal. It's a decimal with lots of different decimal places. So I'm just going to leave this as a fraction in my calculation so I'm not worrying about creating issues by rounding prematurely. So the first step is to do your hypothesis test. We need to know what is H0 for the problem, what is H1. And I'd encourage you to pause the video right now and write down what you think H0 and H1 is. When you're done, unpause to check your work. So here, H0 is at our proportion. We care about it being, we're interested in seeing if it's more than 30%. Now we know we can't test that immediately. We first assume that it's equal to it. And then we're going to see is the proportion for our alternate hypothesis more than is greater than our 0.30. Now step 2, as listed out here, is that you find the level of significance. We're going to record that here. Alpha is 0.05 level of significance. Step 3 is to calculate the test statistic, the formula of which is described in our chart. So we'll record that. It is sample proportion minus P0 divided by the square root p naught times 1 minus p naught, all divided by n. And we've identified in the problem what is our n value, what is our p hat, what is our p naught. Now I'd encourage you to take a moment, pause the video, and calculate this value, round it to 2 decimal places. When you're done, unpause to check your work. Here, whenever we type this into the calculator carefully and round to 2 decimal places, we get 2.29 as my test statistic. Now, for this problem, I'm choosing to complete it using the critical value method. And let's just look over what we need to figure out. So we know that we're dealing with a right-tailed test because we care about seeing if the proportion is greater than 0.3. So I'm looking at my right-tailed column, or row, excuse me. My alpha level of significance is 0.05, intersect that. So the critical value I want to write down is 1.645. Next, as we consider step 4, we can determine whether to reject our H naught as follows for a right-tailed. It's if your if your test statistic Z is greater than or equal to your critical value Z alpha. Now here, we found that our test statistic Z was 2.29, and indeed that is greater than or equal to my critical value of 1.645 from the chart. So from this in step 4, we know that we will reject H naught. Now that we know that we reject H naught, we know our final step is to just formulate a conclusion based on the phrasing of the problem. I'd encourage you to pause the video right now and practice forming that conclusion. Unpause to check your work. And our conclusion would be that we consider that more than 30,000 of people have considered a career, or not 30,000, excuse me, more than 30% of people have considered a career in science. So our next example says it is reported that the mean area of homes built in 2015 was 2,467 square feet. Assume that a simple random sample of 20 homes built in 2017 had a mean area of 2,543 square feet with a standard deviation of 225 square feet. Assume the population of areas is normally distributed. Can you conclude that the mean area of homes built in 2017 is greater than that of homes built in 2015? For this, use an alpha equals 0.01 level of significance. So we know before we begin our hypothesis test, I first need to identify what method for the hypothesis test will I use based on the phrasing of the problem. That is always our first step. So take a moment and pause the video right now, and based on the wording of the problem, ask yourself first, am I dealing with the mean hypothesis test or a population proportion hypothesis test? If it's population proportion, there's only one option. If it's a mean, you then have to ask yourself the additional question, well, do I know the population standard deviation, or is the population standard deviation unknown? So pause the video and think about that. So some key things that jump out to me is the question that I'm interested in is mean area. So from that, I know I'm dealing with a hypothesis test for the mean. Now reading that further, we can see that we're told that there's a simple random sample taken, and I'm given information about that simple random sample mean. So that's our sample mean. And then the sentence continues to give me information linking this standard deviation to the sample. This is my sample standard deviation. So while a standard deviation is mentioned, sigma is unknown because sigma is the population standard deviation. That's why we know we're dealing with this method. We're looking for a hypothesis test of the mean when the population standard deviation is unknown. Once we know the method, we read through the steps and we begin an orderly process. So let's extract some key things from the problem. First, we know our sample size n is 20. The sample mean is 2543. Sample standard deviation is 225. I'll also record my level of significance as 0.01. And in particular, if we look at the steps for the hypothesis test of the mean sample deviation unknown, population standard deviation unknown, we see that we're going to have to use the student's t-distribution, which has to do with degrees of freedom. So at this moment, since I need to know the degrees of freedom, I might as well write that down as part of the information I'm gathering. Remember, the degrees of freedom is the sample size minus 1. So as you've been working through some of these problems, if you're still having trouble, I would encourage you to, before you even work on more problems, really look back through our notes and read through what makes these 3 tests different. Because if you've got a good idea of what makes the 3 tests different, then you'll be better able to actually go through the steps described in the test. So for instance, since I know the mean population standard deviation unknown has to do with degrees of freedom and my student's t-distribution, I'm going to immediately record that as part of the information I extract. So I've got 19 degrees of freedom here. Now, step 1 is always the same. What is the null hypothesis? What is the alternate hypothesis? You're going to gather that from how the question is phrased. I encourage you to pause the video right now and write out both of these. Unpause to check your work. Okay, so here we have to dealing with the mean, so it's based on mu. We're interested if the mean area is greater than that of homes built in 2015. Well, in 2015, cycling back, that's 2467. So before I can figure out if it's greater than, we're going to assume it's equal to, and then our alternate hypothesis will be that actually the mean is greater than that value. So here I'm also going to record at this moment that I'm dealing with a right-tailed test. Step 2, record the alpha level of significance. Here we've been given 0.01. And along with step 2 here, not only do we record the significance level alpha, I also find the critical values using the student's t-distribution. Now, the student's t-distribution is given multiple places in our notes. Specifically, it is within a few pages of where these processes were first described back in the previous section. Let's bring up the student's t-distribution here on the screen. So we have our chart written here. I know my alpha value is 0.01, so I'm looking down the 0.01 column. We see where that intersects with our degrees of freedom of 19. And from this, we see our critical value is 2.539. So next up, we get our test statistic. We can see the formula from our steps described in a previous section. That is that t equals the sample mean minus our mu naught divided by sample standard deviation, which is divided by the square root of n. So take a moment and pause the video, attempt the test statistic on your own, and keep in mind, whenever our test statistic is t, because we need to compare it to our 3 decimal place critical value, we will round to 3 decimal places. And we'll get, when rounded, 1.511 as our test statistic. So finally, since we're dealing with the critical value method, we just need to figure out whether the information we have gathered tells us to reject or fail to reject H0. Looking at the steps described here, it tells us step 4, well, we found that our test statistic was 1.511. Our critical value, T alpha, was 2.539. And the rule says reject if T is greater than or equal to T alpha. So we would need this value to be greater than this value in order for us to reject. We see clearly that that's not the case, so we know in this problem we will end up failing to reject H0. If we were trying to visualize this, once you find your critical value, you would reject H naught if your test statistic lied after it for a right-tailed test. But since our test statistic comes before it, that's why we fail to reject here. Finally, we need to make a proper conclusion based on what we've determined that we fail to reject and the phrasing of the problem. Take a moment and pause the video and come up with your own conclusion. Now, as we're dealing with fail to reject H naught, we've got our beginning phrase that we have to have. There is not enough evidence to conclude, and then we follow up with what we were trying to show. Well, just based on how the problem was phrased, we clearly see what we were trying to show is that the mean area of homes built in 2017 was greater than that of 2015. So we just finish up our conclusion by saying there's not enough evidence to conclude that the mean area of homes built in 2017 is greater than that of homes built in 2015. So hopefully this has given us some additional practice in not only identifying what type of hypothesis test applies in a particular situation, but then going through that test in an organized and detailed manner. As always, if you have questions, reach out via our campus communication, and I'll be very happy to help you.